Okay, so assignment number 3. Now this is actually problem number 10 in the book. The question is, what is the minimum work needed to push a 950 kilogram car 810 meters up along a 9-degree incline? First, part A, ignoring friction, and second, part B, assuming that the effective coefficient of friction retarding the car is 0.25. So, got a nice little free body diagram here. In our free body diagram, the coordinate system has already been defined for us. How convenient. And notice it is in the direction that the plane is going. It makes life a little bit easier. The free bodies drawn for us, we have a normal force acting up, a component of gravity acting down, force of friction acting down, and the force of push acting up. Now, what is missing from this? What is missing from this would be the force of gravity acting down. And that would be the sorry about that. Force of gravity in the x direction. And that, of course, would be the sine component of the mg. Alrighty. So let's break this down. What the minimum work needed would be an infinitesimally small amount above the force of friction and the force of gravity that's pulling it down. So it would be the force of pushing up the hill, would have to be some infinitesimally part so small we can practically call it zero. The force of the push plus that infinitesimally small part is going to have to equal the force of friction plus the force of gravity in the x direction. So if we translate that into work, the work of the push has got to equal the force of the push times the distance that it traveled. In this case, we're going to substitute in the force of friction and the mass gravity sine theta. And that's all going to be times our d. Now, I'm going to do the first one for you because it's nice and easy. Our force of friction is 0. So our work is going to end up being your 950 kilograms times your gravity times the sine of theta sorry, I know what theta is. Totally running out of room. I apologize. times the distance traveled, to give us a total of 1.2 times 10 to the 6th joules. Alright, so why don't you go ahead and pause the video and attempt part B. Now in part B you're going to need to find the force of friction. Okay, welcome back. And for B, I got 3.0 times 10 to the 6th joules. Now, of course, remember I'm going to need to see work on how you got that. And don't forget to also do the other problems on As You Learn. And thank you for watching.